Hello, today we'll be going over the basics of integrals. Before we start, you need to know what derivatives are and how to find them. If you don't, I have hopefully I have a video on this channel that shows you about how to find the derivative of a function. Okay, let's get started. So our first question, what function capital F of x exists so that the derivative of capital F of x is equal to lower case f of x. So we know how to find the derivative of a function. And if we've given one function, we can always find the derivative of it. But let's say we have the derivative of a function and we want to find the original function. So that's basically what this question is. Okay, so we're going to start off like this. We're just writing it in dy over dx form. D of f of x over dx is equal to f of x. Multiply both sides by dx. We have this. And now this is where integrals come in. We are taking the indefinite integral of each side. That's the squiggly s. And when we do that, we cancel out this and the d for this side. And we get to our final result, f of x is equal to the indefinite integral of f of x dx plus c. And I'll get over to why we need that c later. Since integration is technically the inverse of differentiation, d over dx of the integral of f of x dx is equal to f of x, given the fact that we have these two things already at the bottom labeled with the asterisk. Okay, so now we go over to why we have that extra plus c. So let's go over to the first part. F of x equals integral zoom in. Okay, now we should be able to see the screen. So f prime of x equals f of x. So let's say our f of x is, let's say, x squared. And we want to find some kind of f of x, capital F of x, whose derivative is equal to x squared. If you know how to find the integral, or at least the indefinite integral of a power, what we can do is we just take, if we want to find the integral of x to the a, excuse me, x to the power of a dx, that equals x to the power of a plus 1 divided by a plus 1. So if we plug in 2 for this, then f of x should equal x cubed divided by 3. And if we take the derivative of this, we go over to the graph on the left, let's take the derivative, d over dx, that definitely does look like x squared. However, if you continue looking at this, let's add 2. Well, the derivative is still the same, because the derivative of a constant is always going to be 0. But now, as you can see, why we call it indefinite, we don't know which one of these is going to work. We can even do plus pi over 6 squared. And it will, the derivative will always be x squared. So that's why we add the plus c to account for any extra constant that happens to show up. Let's get rid of all of this. So a few extra rules, like taking the derivative of one function plus another. If you want to take the integral of one function plus or minus another function. You can take the integral of each function, add them together. Just remember to add the constant on the end. If you're taking the derivative of one function times a constant, it equals the constant times the integral of the function plus the constant that we always need at the end, the plus c. And the integral of a constant is that constant times x plus c. Okay, so here's our second problem. Our first problem was that general question. So the derivative of r with respect to theta equals pi. dr over d theta equals pi. And now we want to find what r should equal to. So what we can do is we can multiply both sides by theta, or at least for this case d theta. We can now take the integral of each side. And if we remember how to find the integral of this, for always the plus c, r should equal pi theta plus c. Don't mind that add slider thing. I'm just using this to show all the numbers you need to solve this. And if we go back to our original question, now we're finding the derivative of, just to check, we're going to take the derivative of this function. And as you can see, it even writes out in decimal notation, our derivative is pi. So that's our first question done. Here is the second question. We want to take the integral of this, but how do we take the integral of the product of two functions? We don't know how to do that yet, but there's another way we can do it. We can expand this out. It's a plus b times a minus b, so it's a difference of squares. X squared minus 16. I want to take the integral of this. Remember to add the dx on the end, the plus c, to just remember that there's always going to be something afterwards. Now what we can do is we can use that sum and difference rule, take the derivative, integral, still stuck with derivatives, take the integral of each one, minus, that sign stays there, 16 dx plus c. Technically we can also write a plus c in front of this one, but it doesn't matter since c represents every possible constant, including itself times 2, itself times 3, any constant there is. As long as it's real, c can equal that. We find the derivative of each of these. Oh god, why am I saying derivative? We find the integral of each of these. And if we solve from before, this should equal x cubed over 3 minus 16x plus the constant. The way I like to remember this is how we phrase that first question. What function capital F of x exists? So it's the derivative equals lowercase f of x. And that's how I solve each of these problems. Let's do our final problem. This one is going to take a little bit, but I think I can show you well how to do it. We will take the integral of sine of x divided by 1 minus sine squared x dx. So, how do we approach this? We definitely do not know how to find it of the quotient of two functions, but we do know our trig identities. And we can rewrite this out to cosine squared of x. And then now we can rewrite this out to sine over cosine is tangent x secant x, because we're just going to change that 1 over cosine to secant x dx. Now if we know the derivative of a function, what is the original function? If you remember your derivative of trigonometric functions, you should know that this whole thing equals secant squared. Not secant squared, secant x. So let us do this. And you shall see. So first of all, these two might not work together, but now we can do d of dx. Ooh, what are we doing wrong? Okay. So we look like we got something right. Sine of x divided by 1 over... Oh, what we're doing wrong. Now you see it. We were flipping them inside out. I was taking the derivative of the wrong function, but as we can see, the derivative of secant x equals tan x times secant x, which means the integral of this function equals secant x. Just write this in for emphasis. Dx equals secant x. And just to finish it all off, d over dx of secant x equals tan of x times secant x. And that is that problem done. Okay, I hope you understood at least the basics of integrals, what an integral is, knowing that it's technically the inverse of differentiation, why we always add that extra plus c for indefinite integration, a few extra rules, and some problems that we just went over. Okay, hope you enjoyed. Like and subscribe, send this to anyone who needs help, and I'll see you soon. Bye.